The file I would like you to open is this file, parametric building for day 3.1 _rev.th. And if you open the file, you will find the file that you're seeing in through the video. And if you have some problem, please contact me or write something on the chat area. I wait for 1 minute more, and then I will slowly start today's session. I will slowly. Okay, then I will slowly start today's session. I start with introducing what we are going to do. Okay, one moment. What you see in Rhino is coming from Grasshopper, or have you opened the first file from day one? Okay, so the answer is everything is from Grasshopper. I haven't. I don't have anything in Rhino. So what you're seeing is this component. From workshop components worked. So this is the kind of answer component already given beforehand. And my plan is to make each component during the session with you. Yes, and let me introduce quickly what we are going to do. And the first task is called task 4. So the first task begins with number 4 in my session, and it will end at task number 7. And with task number 4, so this input is what I made from day 1's result. So there are 76 BREPs inside the this BREP containers. And in task 4, we are going to separate column BREPs from slab BREPs. So this is task number 4. And then with task number 5, I continue with introducing the feature of selecting columns, but on specific levels. So this, what you're seeing in color green is the selection of the columns of the story number 3. And so this feature I'm going to introduce in task number 5. And task number 6 will take over the slab BREPs from task number 4. And I introduced to calculate the floor area of each surface, and also I try to extract only the top surface of the slab BREP. I hope I can do the preview. Yeah, here you go. So out of this slab BREPs, I try to extract the only top surface so that I can calculate the flow area of each surface. And then if there is still time, I think I want to introduce quickly this facade developing element. So this component will take only the slab edges of the of each levels, and by loft command that you have used in day one, but in C# script, I will make this facade surface by connecting all the edges of the floor slabs. So this is the outline of the session. If you have question or if you haven't been ready, please let me know at this point. I wait a little bit more. And also, if there is a time, I prepared one more additional feature in C# script component where it will take one specific path, and in this path there is one CSV ready from yesterday's session, and I coded something here to read the CSV and extract the point coordinates data. And there is also one additional feature to export into a CSV file. Okay, I have a question from, a machine is responding. Yes, there is no file you have to open in Rhino, and everything is in Grasshopper. Okay, so what you're seeing in, here is the preview from my Grasshopper input. So this you need you may need to enable preview by center clicking the mouse and select this human's head, enable preview, and then this model appears. So once again, to show this model in Rhino screen, go into this Brep. Yeah, as Martin posted in the comment, and either center click or right click, and select this human head, enable preview, and then you will get this model appears in Rhino screen. Has your problem been solved? No. Okay, yes. Okay, so probably the thing you may have to do is to adjust the Rhino screen. So your model might be too slow, too small, or too big. So to adjust this, you have to right-click in the canvas of the Grasshopper, and then select zoom. Then this will set the Rhino. Okay, it's visible when you select the Brep, but the preview isn't turning it on. Visible when you. Okay, is this something to do with this button? Yes. Okay, in this case, I think please try to click on this green icon on your top right corner. Okay, so it worked. Does anybody else have still a problem? Okay, okay. Yep, perfect. Okay, yes. So we can then slowly start. Okay, so the task number 4 I will introduce. So the task is again to separate column B reps and slab B reps, and your component to work in is prepared above your above this component. So this is the component where you can work, or we can work together, where I have already copy and pasted the thing we have to make for the procedure. So this component we are going to use for task number 4. Yes, so then I will start working it. So first thing I have to do is to change the input name. So here I have input X. So right click on the X letter, and we can type in B reps. Then also we have to change the access to list access. And we also specify by right clicking it again the type hint to from system.object to brep. So I made 3 things. I changed the name of the input from X to breps. I changed the access type to list, and I changed the type hint from system.object to brep. So three changes so far. And I don't require Y input, so I eliminate this Y input by zoom into the component and clicking on this minus button. So Y disappeared. And I connect this brep container to brep input, brep's input in our new component. And then I think we can prepare the output also at this point. So the output we have to prepare for is our columns and slabs. So I zoom in to the component, and I press the button, press the plus button here on the output side to increase the number of the output. And then I change the name of input A as columns. And also I change the name of the output B as slabs. If you have a problem, please write something on the chat box, or please tell me in any way. So then I think we are ready in coding something in the components. So by double clicking the center of the component, this script editor will show up. Yes, and let me introduce what we are going to do. So first, we are going to prepare 2 lists to store columns and slabs respectively. So this is something to do with the output. And then we are going to make a for loop with breps input. And inside the loop, we are going to calculate the height of each element. So I will introduce this PowerPoint slide afterwards, or even now, I think. So this is the algorithm we are going to make for task, actually task 4. So we have to, in order to get, in order to separate slabs from columns, we are going to use this bounding box feature, with which, if you have an object in 3-dimensional space, this bounding box feature will create a box or cuboid, which is aligned to XYZ global coordinates. So, and this bounding box has the properties of minimum corner and the maximal corner, which are in point 3D type. So you can extract Z coordinate of the top and bottom of the BREP. So this is one thing we are going to do. And then in order to get the height of each element, obviously we need to subtract this max Z coordinate from minimum Z coordinate. Then we are going to have a BREP height. And the way I plan to separate floor BREP, column BREPs from slab BREPs is by using the nature that the column connecting top and bottom and top floors, and therefore it is, or they are typically more than let's say 2 meters or even 1 meter. So by introducing if statement, if a slab's height is more than, let's say, 200 centimeter, then we can say that this is a column BREP. Otherwise, it is a slab BREP. So this is the algorithm to do this job. And then we store the BREPs accordingly in the separate list. So let's start coding. So first, I prepare 2 lists containing the BREPs. So list list, and the type is BREP, and I call this calls column plus plural s calls equals to new list BREP. The same procedure that we made yesterday with machine. And bracket and semicolon. So this will contain column BREPs, and another list is the same list BREP, and in this case slabs SLBS equals to new list BREP. New list BREP and brackets. So if you have problem, please let me know. Then we are going to make create for loop. So let's revise a little bit about for loop. So for loop, you have to create integer with which we are making a kind of counter of the for loop. So for int I equals to 0. Okay, so sorry, I forgot to magnify a little bit for the visibility. Yes. For integer I equals 0 and semicolon. So I, how many times do we have to make? Make this loop running? So it's as much as the number of this, as many as the number of these BREPs. So far we have 76. So this can be counted by the property of list of these B-reps. So B-reps dot count. This is the property which returns the number of the containing elements. So in this case, this will return 76. And then I equal I plus 1 or I plus plus in short. Then I made this curly bracket. Okay, one closing bracket should be the end of the loop. So I place one here. And we have to create an algorithm then to calculate the height of each element. So for this, I will try to introduce a new feature, which is called method. So instead of writing something directly here on the main coding area, I will make use of this additional coding area here. So to get access here, I can create a small method. So after this algorithm, what we want to have is the height of each element. So the returning value from this additional coding area should be number and or double. And let's name this as height equals to, and I proceed with the method part. Get height of a vrep. And here I need one argument or one input variable, which has the type of vrep, and let's call this as okay. So vreps and i's value of vreps. So what I have done here is to get one vrep in for loop, which is sorry, I don't need this type indicator here. Sorry. So vreps I. So I take this vrep and I put this in get height of a vrep, which we are going to make as a method, and then this method will return the height value here. And how to return the height value here is what is the thing we are going to observe. So let's copy this get height of a vrep text by pressing Ctrl C, and let's go down in the additional coding area, and let's paste it here. Get height of a vrep, and I need a bracket, and here I type again the input variable or arguments. In other words, vrep let's call this brp, and then we need to prepare a curly bracket which indicates the contents of this method. So again, I move this closing bracket to the end of the method here. And this is here. I have written the procedure to get the height value of a vrep. So I think we can follow this procedure now. Okay, and one thing. So this method needs to return a double value. So here I have to type in the type of returning value. So in this case, it is double, So we are going to return the height value, so it is double. So I wrote here double. Then we can continue. So the first thing is to obtain the bounding box of the Brep. So the bounding box is this thing, and yes. So if you have okay, so let's start by defining it. Bounding box with both be capitalized, and I call this bounding box as BB equals to. So this can be obtained from input variable, this Brep. So imagine this is either a slab Brep or a column Brep. So this is one Brep. So this Brep has properties. Oh, let me see. Oh no, excuse me. Has a method which is called get bounding box. So I select it, or you can type in as dot get bounding box. And as this is a method, I need a bracket here and semicolon here. I hope you're following me still. And this method, if I go back to the PowerPoint, requires one input argument, which is Boolean type. So in other words, true or false. So it behaves differently according to this true false value. So if you type in true value, then as I highlighted in yellow, it will return the accurate bounding box. And if you otherwise, it will return rough bounding box. So accurate bounding box will require more computing, but I think we have just about 100 elements. So I think we can go for this accurate method in this case. So I type in true here to get the accurate boundary box. Then I move on to obtaining a z-value of max corner. So z-value is obviously has double type. So double max. So let's call this max z equals to bounding box, and it has max corner, max properties, which is in point 3D. And then as this max property has the type of point 3D, it has property of point 3D, and which we can make use of. And in this case, we select Z property. So this will return the Z coordinates of this max corner. Let me, or may I continue? Let me know at any time that you're in trouble. We are three in this room, so I think the other two, Machine and Sverre, can respond. If not, it is not by me. Okay, so let me continue. So we obtain in the same method the minimum corner coordinate of z value. So double min z equals to bb dot max dot z and semicolon. So with this, we can finally calculate the height of a Brep. So this should be double height equals to max z value minus max minimum z value. And this method needs to return this double height to the main coding part. So return this type return and this height value. So this is the end of the method. I think it is a good practice to run script from time to time so that you can find any mistakes in advance. Okay, so there is a question. Shouldn't you write? Pardon? Okay. Yes. Yes. You're right. Yes. Thanks for telling me that. So this should be not max but min. Yes. Thank you for this. Yes. So I think you're referring to the same part, right? So yes, it's my mistake. Sorry. Yeah. Thanks. So let's go back to the main part. So by now I think we managed to get the height value of a brep. So then let's write the judging part of slabs and columns. So according to the height value. So here I use if conditional statement. So if bracket height, I hardcode the value here. If height, let's say 200 centimeter, then I need to prepare curly brackets. Then so I place a comment here. Then a column brep. So I want to store this brep in columns or calls list. So to store brep in a list, you have to specify the list first and then dot and add method. And this what we are going to store is not the height itself, but this brep element, right? I see. Yeah. Okay. I should have written this part here. So I just change the comment position. So we have done with if statement. So we continue with else. So if if height is more than 200 centimeters, it should be column, and otherwise it should be this is a slab. So SL, what was the name of the list? SLBS slabs, and add breps I. So we have done the things in the loop, and then what we have to do is just outputting. So the output a variables are columns and slabs, which is here. So okay, so do output here. We assign these values to columns and slabs. Columns equals to cols, and slabs equals to SLBS slabs. And once finished, I check how it works, run script. So I have no error. And if I close this script part, you have something right in green color. The problem is the output we have is now columns and slabs, so both. So we can check by placing a brep container here. If you type in brep and select this icon with black background, then we can insert, for example, columns brep, and then you will see that these columns are selected successfully. And I think it's the same applies for the slabs element, right? Okay, so we have gone through this task number 4, which is my first task. And as you recognize, you have already the answer here. So if you have problem, you could also go into this already made script part. So almost the same things is in this worked script components. So I think we are going to have a short break here, and I think 5 minutes will do. So let's go. Let's come back at 9:43. Let's let's do it in 45. 9:45. We will start. Okay, the time is 9:45, so let's begin. We have one comment. Do we have additional advantage feature in Grasshopper C# than in Dynamo Python? Maybe you could respond this. Okay, so let's start. Yes, and in task 4, the previous task, I have introduced one example of using a method in this additional coding areas. This might be a bit advanced from the beginning. So let's go back a little bit to the primitive example. Actually, I have already prepared for this. So in the Grasshopper file, can you zoom into this left bottom corner? This component. So I think with this component, I would like to explain the basic of the usage of the method. And if you double click on it, I have already something written there. So let's comment out. Let's comment out 2 elements from the main code. Double deg equals something and deg equal degree equal deg. And yes, and here we have one method left, which is called print hello. And it doesn't require any argument or any input variables. And how this code will work? When it runs, it goes to the main coding area, and then it goes to print hello method. So from here, the code will jump to the additional coding area, and here we have a print hello method already written. And in it, I prepared print command, and the content is just hello. So if I run script, it will return a hello value. Just to confirm, let's change the text inside hello world. And then I press run script, and then you've got the updated text here. And if you observe the type of the method, it has a specific type called void. This is a specific type. It doesn't require any returned value from this method to the main code. So this is the example of using void when you don't have the returned value from the method. Another primitive example is, so let's comment out this print hello now on the main code by // with a little feature of converting a angle value from where from let me see. Angle to degree sounds a little bit weird. This is a degree to radian, right? Sorry, I made a mistake here. So let's correct this. Yes. So this the intention is, excuse me, this is I have made another mistake here, but the intention is take a degree value. So please correct me. So the input should have code degree here. So this I have made a slider from ranging from 0 to 360 degree. So the type is in double. And then this angle to degree sounds a bit weird too, but the intention is to convert this value from degree to radian value. So let's make this feature by correcting what I have prepared by mistake. So the main code. Right. Okay. So yeah, as Martin suggests, I have to if I have changed the input value here, in order to update the what's written here as input value, I have to close the editor once. Select OK. The component turns red for the moment, but it doesn't matter. And reopen it, and then you see the new input variable here. Okay, so I made another mistake. Sorry again, many times. Now you see this input and output. We have the same variable. So let's close this editor once again. Excuse me, I apologize. And let's change the output value then to degree to radian. Then I double click and I have editor with updated input and variable names. So I can continue with correcting myself. So the first thing is to define the return value. So the desired return value is now radian, but I cannot use radian itself because it is already used in output variable. So let's call this as rad. And I am going to change the name of the method here. So I will change this the name of the method to degree to radian. And here, the argument or the input variable required is not angle anymore, but it's now degree. I copy this this part highlighted now by Ctrl+C, and I go to this additional coding area, and I select this old method name, and I replace this to our new method name, degree to radian. And this will take double type an A. It meant angle, but this is wrong. So let's change this as D, or yeah, as I change this as degree, deg, DEG. And here, degree can, no, radian. It's a bit confusing. So what we want to have is radian as return value. So let's prepare radian, rad, and it should be degree. I think the equation itself is also wrong here. We have to introduce pi. It's totally wrong in some way. It's a bit strange. So what's the equation? The converting equation from degree to radian. So suppose we have 100 degree. So this is corresponding to the value of pi in radian. So so the value should be degree divided by 180 times pi. And for pi, you can type in the value directory like this. Alternatively, if you want to have more precision, there is a mass library in the system class where you have properties of pi. You see now you see a series of mathematical functions, and in it there is a pi properties. So with this you can have more precise value. And let's set this rad as returned value. So going back to the main area, so this degree to radian method will return the value in radian. So what we have to do is to relate this value to the output value, which is not degree anymore, but now it has the new name of radian. Radian is, and also rad here. And I run script, and I see what's inside. Here we have 2 times pi against the input value 360 degree. So if I change the slider, so if you double click on the slider, you can change the value to the exact number. So 180 is pi, and 0 is 0. So I think this is correct. And so this is the by my mistake, I spent 12 minutes for this, but this is representing or this is showing the basic usage of the method in this additional coding area. So let's get back to the task, our task again. If you get confused of a series of my mistakes, please don't hesitate to write to contact one of us in the chat area. And yes, let's go back to the our task number 5. So this task is to select columns on specific levels. The input is the result of the task number 4. So let's start this. So I have prepared this blank C# script component with instruction inside. So let's use this. So I relocate this a little bit here. And the input, we need to change again from X to cols, representing columns. And I have to change the access type from item to list, because it is going to be a list input. And then I have to also to change the type hint from generic to brep type. So I change the value of the input name. I change the access type to list access. I changed type hint to brep. So this is for the first input, and second input is this kind of or selector of the flow levels. So we have to create slider ranging from 1 to 3. And we have to also change the name of the input and also the type of the input. Here we are going to prepare slider by double clicking in an empty area in the Grasshopper canvas and typing 1.3. So this will create slider ranging from 1 to 3. The type is integer in this case. So it has either value of 1, 2, or 3. And then I will change the input name here from Y to N. And also I change the input type to, in this case, integer, so int. I connect the slider to n input, and also I connect this colors input to the columns output of task number 4. Is it okay so far? Okay, so let's get in the code by double-clicking the center of the component. Okay, so okay, so let's go to the PowerPoint slide. I want to go to page 6, but somehow I don't have the control for this PowerPoint, so I need to open. Okay, sorry to have kept you waiting. So here, the task is to select the columns on specific levels. So we have to come up with a own algorithm to do this because no pre-made method or properties are there for this functionality. So we have to come up with an algorithm by ourselves. So there might be some better algorithms than I have come up with, but this is one of the example of the one which is working. So the algorithm I came up with is first to create a list containing all the z levels. So in this section, for example, this is a section of our buildings, and we have 3 levels except for the roof, and we have so z equals 0, either 0 or 400 or 800. So I want to have the list containing these values, so 0, 400, 800 in ascending order. And here we have this slider that we have made just now. So by algorithm, if we select one, we want to have this level 0. If we select 2, we want to have z level 400, and 3 for 800, and so on. And this is the proposal from me about this algorithm. So I explain a little bit. So for each item, so for each column Brep, we could obtain minimum z value by using similar procedure from task 4, the previous task. And if minimum z value is not in this z level list, we should add this value to z levels. And otherwise, we should do nothing, in my opinion, because otherwise the list contains multiple elements with same z levels, right? So we want to have only 0, 400, 800, but if we do anything and add elements in this z level list, we end up having 000s and 400, so on, 76 70 two elements in the end. So this we don't want to have. So we want to have this. So if the minimum value is already appeared in the list, we should do nothing. So after this for loop, we are going to have more or less this kind of list. But one tiny problem is it can be depending on the order of the brep container. It can be instead of 0, 400, 800, it can be 400, 0, 800. Then the slider value and the actually selected floor levels doesn't correspond. So as a final touch, we need to sort the list in ascending order, which is quite simple by executing one method, which is called dot sort on the list. So this with this in mind, we can go back to the code and we start the code. So first thing we have to do is to prepare a list to contain a selected column. Okay, so we actually I have to prepare for the output as well. So apologize once again. Let's close the editor and prepare for the output now. So we need two outputs. One is for the selected columns, and one is the Z list itself to check if the list is working correctly. So I increase the number of the output by zooming into the component and press plus button here, and I change the name as from A to selected columns. Selected columns with C capitalized. And the second output I change from B to Z list. Okay, with all this preparation, we can get back in the coding. So our task was to prepare a list to contain selected columns. So it is easy by now, I think. So the list type is brep and selected. I name it equals to new brand new list of brep type and brackets and the semicolon. So it's done. So the second thing is to prepare a list containing Z levels. And I wrote, let's do this as a method. So let's do this. And we have to keep in mind that there should be no duplication of the same floor levels, and it should be in the ascending order. And the returning value from this method is also the list containing all the floor levels. So the floor levels should be given by the type of double. And I call this as Z levels. Z levels equals to the method name we are going to create. So I name this method create Z level list. And I need columns brep as an input. And I finish with a semicolon. Just to check if I made any mistake so far. And I actually did. Let's see what's inside. Yes, the name create Z level list does not exist. Yeah, this is true. We are going to make. So let's ignore this error message. And let's copy this long name so that we don't make any typo here. So in the additional coding area, we will do the coding of the inside of this method. So let's define the method first. The returning value is a list containing all the z levels. So the type of the returning values should be also list, and the z level should be double. And we copy and paste, we paste this name, create z level list. And the input variable or argument is list type and brep. And this was the brep of columns. So let's call this as columns, cols. And we open the curly bracket and we place the closing curly bracket at the end of this method here. I hope you're following. Yep. Okay, so let's proceed. So the first task in this method is to create a list double for the returned value. So let's call this, let's define and the list of double. And let's call this as z levels equals to new list of double and bracket and semicolon. One thing worth mentioning here is that we have similar variables already, z levels, and we have exactly the same variable name in the main coding area. It is acceptable because the variables defined within a method is valid only in this method generally. So this value won't come out directly from as z level with the name of z levels outside of this method. So so it is acceptable to use the same name variables here. So okay, so let me continue. So for loop for each column brep. Here I wanna introduce one other another or alternative for making for loop. So by now we are using all the time this for integer I equals 0 and counter. Instead of this, I can or we can write for each statement for the looping. This is just alternative. Both works quite the same way, but yeah, sometimes sometimes it is one is convenient than the more convenient than the others. So let's try this for each statement. So in this case, in the case of for each statement, we need to define in this case brep. Let's call this brep c in cols. So this is the way that or the syntax of the for each. So instead of introducing integer I for the counter, for the looping counter, we can have directory each element of brep in the brep list. So brep list is cols. So and each element in every loop is element C. So it's like having a container of columns containing 72 elements, and we take brep C one by one, and we do some operation inside the for each loop. So this is a simple explanation of this for each. And yes, I should have placed this closing curly bracket at the end of the loop. End of the loop is here. So I copy and paste the closing curly bracket. So what we are going to do in this for loop is obtain the bounding box of the column. So this we have done once, right, in the previous task. So let's do this. So we have to define the bounding box. I call this BB equals, and the element in the loop is called now C. So let's take this C Brep. It is one column. So one column has the method of get bounding box. And if you remember, we have to input true false value depending on the precision that we wanna have. I wanna still have high precision, so I type in true. If you prefer the first operation, you should type in false here. So this will get the bounding box from one column and get the minimum z value of the column. So this should be, this is easy, right, by now. So double minimum z equals to BB. It has so bounding box has the property of minimum corner. So minimum corner. So this has now 0.3D type, and the 0.3D type has z value as properties. So this is to get the minimum z value of the column. And next item. So if the z value doesn't exist in the return list, add this z value to the list. So we have a z level list, and if we don't find this minimum z value already in this z level list, we should add this value. Otherwise, do nothing. So let's create this type, this part in if statement. So if bracket open, and what we have to do is take z levels list, and the newly introduced method here is capitalized C and contains and this minimum z value. So I prepared this curly bracket. So the explanation of this dot contains method is to that this will check if this list contains this value, and it returns true if it has if it finds the element of the same value as mean z value. Otherwise, it returns false, and we want to have false here. So this is the condition. So if z level dot contains minimum z equals false, alternatively you can write this statement as if this symbol exclamation exclamation z levels contains z. So this exclamation represents negative. So if this statement equals negative, by which I mean the false value, so you can write in either way. Yeah, if you can say if not. Okay, so we should add z levels list, add this minimum z value, and semicolon here. So by looping this algorithm as many as the number of the columns, the levels will eventually complete, and it will let's return this value to the main part of the coding area. Oh, one moment. We have to do the sorting of the list, right? So the levels dot sort should do the work, and then return the levels. So this value will go up in the main code to this part. So by now we should have obtained the complete list of z levels. So let's check this by printing, or printing. No, we have already this z list output. So let's make use of this. Z list equals to z levels. So I run script, and I don't have any errors. If I open a panel here, // is a shortcut for panels. And if I connect this, yeah, it seems it is working. So we have a list containing flow levels. So 0, the index 0 representing the first level, and 1 the second level, and so on. I think I have to be a bit fast here. So let's continue with the coding. So determine the target z level using input n value. And as I stated before, there is so this input. I want when I have this zeroth element, the input is actually 1. So there is so we have to be aware of this difference in counting the numbers of the index. So 1 actually refers to the 0th element in the list, and 2 refers to the first element, the first element in the list. So we have to consider this as well here. So I will define the target z level. So I call this double target z level. So with this double, I wanna obtain this z level value. So if the slider is set to 2, I want to have 372. So to do this, I can go into z levels list that we have created, and take not nth element, right? There is a difference in the index. So if n equals to 2, we want to have first element in the list. So this is the thing we have to consider here. Then we have another loop here for each column to get finally the column B reps on the specific level. So let's do the loop. Maybe this time again for each statement. So for each B rep C in column list, I open curly bracket here, and I close the bracket somewhere here. And inside of the loop, I want to have a minimum z value again. So this is the same procedure as previous. So double minimum z. So let's combine instead of defining bounding box BB, so on, maybe we could also directly get the height minimum Z value. So the Brep is C, and it has the get bounding box method. I use here again true for the input variable. So this will return the bounding box type. And bounding box has the minimum or min properties. And this is now, this part is now representing a point 3D type. A point 3D type has properties of Z value. So this is actually the faster way of describing this procedure. So C dot get bounding box true dot min dot Z should obtain the minimum Z value of a column. Finally, so compare with the target Z values. So by target Z level, I selected the specific level. So let's assume I selected the second level, 372. So if I, for each column, I compare this 372 with column minimum Z value. So if these correspond or these matches, I put this value to the output list. So this selected. So let's write this part. If minimum Z equals to target Z level, curly brackets, and then selected, add selected. So this is the name of the output list, and dot add method. I can add things. Brep C. We can have this else statement for doing nothing like this. So continue is one operational statement that we do nothing, and you can do this, but also you can omit this part in this case. I think it will do the same thing in the end. Yeah, I think we can go without this, or just, yeah. So this is the end of the loop, and I set the output value finally to selected columns output variable. Selected columns equals to selected semicolon. So I have run the script here, and let's see how it works. Yes, now I think, I hope not only me, but also your code is outputting these columns with on specific levels according to the number of n value. Okay, so thank you for attending this long session. Let's take a break, longer, smaller, 10 minutes. Yes, let's come back on 10:40 then. Yep. See you soon. And if you have questions, let me know during the break. Yes, welcome back. So let's continue with our task number 6. And I recognize that by now we have a lot of elements showing overlapped. I think we should preview of some of the components. I think we don't need the component we have created for task 4 and 5 and some Brep component container here. So I selected this and I press the center wheel button on my mouse, and I'm going to press this disable preview with human head with black band on the ears. No, eyes. Then I have only one element left. Oh, actually, there's one more. Yeah, there's one more from my prepared components. So let's disable preview. And with this task number 6, what we are going to do is so from task 4, we are going to take slabs as input, and we obtain the top surfaces of each top surface of each is slab, and calculate the area of the surface area of each floor level. So if I go back to my PowerPoint, yes, this is yes. So this is representing one slab on a level. It is now consists of I think multiple faces. We have at least top face and bottom face, and we have several side faces. And our task is to get only the top face of this BREP. BREP. So this again requires some procedure that we have to come up with by ourselves. And so this is one example of this kind of procedure. So as I mentioned before, there should be something better, and this is one example which works. Yes, so let's or let me explain what's inside. So if I have a BREP on a level, so it is it consists of multiple faces. So first, I think I want to get the centroid of each surface. It doesn't necessarily be exactly the centroid, but it gives one point containing z level of this of each BREP's face or BREP face. And so by using this z level coordinate of centroid of BREPs, we can sort the surfaces by this value in the descending order this time. So that if we take the first element, it will be the top surface, right? So the top surface z coordinate will be the highest z coordinates among BREP faces of BREP on the level, on the floor level, right? So this is the idea. And how can we get a centroid of each surface? And there is one class dedicating to this specific feature, which is called Rhino.geometry.area mass properties. And there we can, by using this, we can have a centroid parameter and area parameters. Okay, I think then I would like to go to the coding part. So, so let's take this brand new component, C# script component for task number 6 with instruction inside. I want to relocate this component a little bit towards right. And yes, as always, I want to prepare input and output of this component. So the input variables is called slabs, meaning flow slab, and S for plural S. And it should have a list access. And also it has the type of Brep. This is the input variable part. And I don't need this Y, so I zoom into the component, and by pressing this minus button, I eliminate this input Y. And for the output, there are two outputs. So one is exporting the surface areas of each surface, and one is exporting the top faces. So let's prepare this too. One is area, called areas, and one is called top faces, right? And I connect the input value from the output of task number 4, slabs. I should have selected this slabs. So by extracting wire by light mouse button and click, and in my case, it's a bit far away, my component, to connect from this to there. So what I'm doing now is keep holding the left mouse button by keep holding left mouse button, and I use a center wheel to magnify to zoom out a little bit, and by repeating this process, you can reach to your component. And it's just a trick. It's nothing to do with essential. If not, you can just move the component here and connect easily. Okay, so let's open the script or C# script component. So the first activity is this is just a practice. We use this procedure later, but just for practice, take one slab from slab's input. So this is now a list of 4. Just take one and calculate the area, surface area, and the centroid, and output them. So let's start. So take one slab part. So Brep. So this is one slab 1 Brep equals to slabs, and I just take the first element. This is just a practice. It can be 1, 2, 3, 4. Not 4. We have 0 to 3. So let's take either of them. So in my case 0, and get the area and centroid. To get area and centroid, I have to use this area mass properties that I have introduced in my PowerPoint slide. So this has a dedicated class for the calculation. So this is a bit long, but let's try typing it. Area mass properties. So I call this AMP, area mass properties. AMP equals area mass properties dot compute. I will explain this very soon. And one brep. So this is a way that I wrote to get the area mass properties, and this compute thing I am explaining now is here. Yes, this is the from the web page of Rhino Common API website as Marcin introduced yesterday. So I also visited this site by typing area mass properties Rhino API in Google, and I get I reached this website, and I copy and paste here. And here in the method part, we have this compute surface method. This could be used, and it has a small icon with the character with the letter S, and S means what we call static method. So by static method, I think Marcin will introduce how to construct a class. But for the moment, let's understand that this requires no initialization of the class instance. So if it is a point, for example, if it is a point, I think we have accustomed already that we have the description like point 3D, new point equals to new point 3D and brackets. So this is the activity of initialization of class instance. And this static method doesn't require this kind of procedure. And instead, it can directly access by typing this class name. I use a short version, but it should be written as area mass properties here, and area mass properties dot. Then this compute method is accessible from outside. Dot compute, and inside you place this surface or brep phase here to get this compute run. And after this method will returns this area mass properties class. And in the property we have in the properties of area mass properties class we have area and centered. So this is something we wanna reach to get area and centroid. And I suppose this is getting difficult, and but sometimes we, there can be no other way but to do this kind of tricky coding. But yes, let's try out this. Yeah, and we have done this actually. So this is the meaning of this area mass properties and compute thing. And so this part is now area mass properties class. So it has the property of as you see, area and centroid. So I can continue here, but as we need to extract both, I think I will prepare separate variables. I think I can call this as test area because this is just a test. And AMP is area mass properties class instance dot area properties of this class. And this is double. And the other thing is centroid. This is in the type of point 3D. So test point is area mass property, and it has centroid parameter. It has, as you see, this 0.3D type. So centroid will do the job. And for the output, I think for the double, I think I want to try out this print command to see the value, test point, no, area. And for the test point, I wanna increase temporarily the number of the output by pressing C. Pressing plus, and yes, now I have the A output. But I suppose I have to close the editor again to get this value into the code. Yes, and I think I have made one mistake here. And let's see what's that. So the error is, I think, yeah, error can be seen from here, but also from here by right-clicking the center part of the component and go to runtime errors. So I have made a mistake in the line number 67. 67. It's okay. So this print part. Obviously, this test area has the type of double, and you cannot directly print this double value in the print command. It has to be converted in the text format. But it's not a big job to do this. Double class has a method which is called toString with T and S capitalized and brackets. So this part will convert double type into text or string type, with which now this part became text type or string type, so it can be printed. So if I connect panel by / is a shortcut for panel, and connect this to output. Yeah, I have some value of test area. Okay, yes. And yes, we have to also set the output for the A output. So test point should be printed out or from this A output. If I hover my mouse over A output, I see some tiny yellow window saying that one value is there. And if I go to the Rhino window, I clearly see that there is 1 point around the centroid of this surface. Okay, so let's get back in the code. So this is just a test. We can comment out, but yeah, we can keep them as it is, as they are now. So let's do the real main part. So the procedure number 1 is to prepare 2 lists for output. By 2 lists, I refer to these two. One is area output, one is output for top surfaces. So we prepare the container or list for them. So one list is has the type of double. I call this areas equals to obviously new list of double and brackets and semicolon. And the second list is list of face. So this is okay. So this is the list of top faces of Brep, and I have, maybe some of you has recognized that I am using the word of either face or surface in an ambiguous manner. So let's see what's inside actually in Rhino common. So if I go into the Rhino common brep class, it has what I have used. Yes, I have used this, or we are going to use faces properties of brep. And if I click this, it will return brep face list. And here you have the link for the brep face list. And this is obviously the list of brep face. I want to go to see what brep face actually means, but there seems no link anymore that I can have access from here. So in this case, I can go back to this side pane and okay, so it's not collections, namespace, Rhino geometry, brep face class. So the accessibility is not very nice. And here we have, and this is a brep face class, and this is the interesting feature that C# language has. It has a feature of inheritance. So this brep face is the class representing the face of a brep, but it inherits the feature of Rhino geometry dot surface. So it can be treated as practically it can be treated as also a surface type, and the opposite is not always the true. Sometimes you can treat surface as brep face, but sometimes not. But if you have brep face, you can treat always this as Rhino geometry dot surface. So this is the unique feature or interesting feature that C# has. Yes, so let's get back. So yes, we were preparing the list of this brep face. Top faces equals to new list of brep face. Sorry, I made a mistake. New list of brep face. Siberi, can you take care of brep face and brackets and the semicolon? Then procedure 2, we are going to have for each loop for brep or slab in slab list. So let's write this for each brep type of slab in slabs list. And I open curly bracket and I prepare closing curly bracket here. So this is a loop through all the slabs here. So here we have to get faces of a brep. So this we have just visited. So brep face list. I think this won't work, but I will continue typing this. Brep face list faces equals to slab dot faces. Yeah, it won't work. The reason is this brep face list is in, I go back, brep face list is in Rhino geometry collection. I think I don't have the brep face list. So it's another namespace, brep face list. I Google it. Rhino common. Before Rhino common, I reached to the page. So this is under Rhino geometry collections namespace. So we have to import this library, the namespace, by using using command at the very beginning here in the line number 13. We could have additional using. So rhino.geometry.collections is the namespace to be imported. Then this top face is no, this brep face class is accessible now. Yes. So we have gone anti-slab faces, and then we are going to have this useful link command. For this, I have to get back once again to the PowerPoint slide. So sorry for my bad handwriting here. So we are going to use a link feature of C#. This is another useful feature of C#. So this is to access to various data in the list or in the collection type in C#. So in the previous task, we have observed preparing a list of, for example, integer containing 20, 10, 30 as values, and this can be sorted by using .sort method of the list, and then we have this ascending a list of ascending values. In our case, this time, our list contains elements whose type is brep face, and we have a number of face, and we would like to be sorted not directly with this value on or not directly by this element itself, but by some value which can be extracted from each element, in this case brep face. So what in other words what we want to do is to get this area of each face calculated and sort the list according to the bigness or the smallness of this area. So in this case, you cannot use this .sort method of the list anymore, and then this link is quite powerful here. And here in the bottom half is the example of using one of the link command, which is called .order by. So as name indicates, this is to order the content of the list with some values which can be extracted from the elements of the list. Here the syntax is goes typically like this. So we have var. Martin introduced var yesterday. This is called anonymous type. So it can be anything. So you don't have to specify it is double or it is a list of some element type, but you can have var instead. And this is kind of a useful feature as well. But if you use too much, you yourself get confused because of too many words, and you don't know what the content type is. And alternatively, you could also write the correct type. In this case, the correct element type is called I-ordered enumerable of Brep face. This is the correct type, but we can use a var. And with link command, it is a quite common practice that we use var to get a return value obtained by a link command. So I think we can use var this time as well. And we have the list of Brep faces here. I represent this as some list. And dot ordered by, this is a link command. And after ordered by, inside the bracket, this is a special way of writing expression, and which is called Lambda Expression. And yeah, you can play with a lot of with this, but I try to explain the very minimum of this. So within this lambda operation, you have a lambda operator, which consists of this equal and larger than sign. And on your left side of this lambda operator, you have input parameter. And for this lambda operation, you don't have to specify the type of this x thing. You can use any letters or without defining the type. So you use I use for example x letter here, and here on your on your right side of the lambda operator, you have the expression. So this is the area that I want to extract the data from x. So this AMP representing area mass properties, you have to write down the correct way. I use a shorter version. AMP dot compute x. X means this the element of some list, and this will return the area mass property class instance, and it has the property of area inside dot area, and this lambda expression together with the link command, it will order the element in some list in the order of the smallness of this area on your right side of lambda expression. If you wanna have a list ordered by descending way, you could use also dot order by descending instead. So this is a very short expression of the link feature. So, and let's immediately use this feature. Our task is here. Link command sort slabs list in the descending order of centroid Z. So can we do this? So we use this anonymous type var order. So this is the name of the returning list. Ordered faces equals to here we have faces as face list of Brep faces, and then I start this link part order. Okay, yes, one thing. For link itself, we have to import additional library, excuse me, using, going back to line number 14, and let's type in using system.link. So this is a library for using link feature of C#. So faces and order by, and actually I want to use orders by descending already because I want to have the top. I want to select the Brep face, which locate the highest of Brep slab Brep, right? This is the top surface. So I want to use order by descending link command here, and I will type in the parameter. So this is faces. So let's name this F, and this is lambda operator equal larger than and here is the expression what with which we wanna sort the inside of this list. So area, mass, properties. I think I can continue here. Area, mass, properties dot compute, and compute this surface f. And this returns area mass properties instance, and then we could have the access for the centroid property. And centroid is point 3D type, so we can have z parameters here, here, and we have to have yes closing bracket and semicolon here. Yes, so this is the link command. And now this collects the faces, but ordered in descending order. So let's take one surface, I mean the top surface from this face list. So brep face, top face equals ordered faces. That's the name that I created for this list. And I was saying list, but this is actually not the list type. So it's a bit difficult, but it's not the list itself. Here, this var type is actually I ordered enumerable brep face. So this is the official name of this collection type. And if this is a list, I might have mentioned somewhere. Okay, but I didn't have. Okay, if this is a list, we could use this expression, right? This square bracket and 0 indicates the index number. But this is not a list. We cannot use this expression, but instead we can use this expression element at instead. And then we should type in the index number of the element. And this, if I may add something, this I, in this case, ordered, but I enumerable type is, I think you can interpret this for the moment that this is a kind of collection type, which is read only. You cannot add element or you cannot delete element. And this is to use to store the return value, which cannot be changed. And this I enumerable type requires this element at expression instead of a square bracket and the index number for the list. So this is a difference and might be a difficulty also. Okay, so never mind. Let's calculate the area of top surface and double top face area equals to area mass properties dot compute top face. And it has area mass properties instance, so it has the property of area, right? So this is the area of the top surface corresponding to more or less the floor area of each level. So finally, let's add these two top faces. Top faces list. Yeah, I prepared here these lists for the output. Top faces at top face at this face, and areas at this area, top face area. So this is the end of the loop, and after repeating this process over all the slab elements collected in the inputs, we are going to have the proper top faces and areas. So let's output this areas with A capitalized equals to areas, and top faces with T capitalized and top faces. Let's see if it works. Yes, we have no error. And as you see, if you select the component, we can observe that we have selected areas correctly. And this is the list of areas. So it has quite a big number, so 8.3 times 10 to the power of 6, because this is in square centimeter. So we might want to add some more mathematical function to convert this square centimeter to square meter, but this I think you can implement by yourself. Yes, and thanks for keeping or be patient with me in the explanation. So I wanna have one more component to explain, but we have 8 minutes more. So let's take a small break of 3 minutes. Then I try to explain this component in 5 minutes. So we meet on 11:25. Thank you. So it is 11:25, and I start with yes, this is my last session. Yes, I prepared task number 7, which is the task of combining link and generating geometry feature. I think it's not possible to do this in 5 minutes by writing by ourselves. Instead, I will explain the contents of this, and I think I also promise that I make a video, one video, to do the to follow the procedure of this component. So, but now for now I explain the content of the this final components. So the idea is, suppose we have a Brep here around this blue surface. The idea is to get this border or this outer curve, edge curve of this Brep. And this can be achieved by executing dot duplicate edge curves method in the Brep. So B dot the duplicate edge curves will make will create or will return the curves here. The problem for the following step to use this for Brep loft. The problem is the returned value is the type of curve array. So this is kind of list of containing curves, but not yet polyline by this returned value. So we have to join curves of returned value by this method together. So curves dot join curves, and this is okay, sorry, the method. And please be aware that this is also a static method. So it starts with directly with this method part. So curve dot join curves, and this is the curves. This returned value is this curves list, and it will. And this join curve method, which I made a copy here, has also the type of curve array. So this is also a list or collection of curves. So, but after joining curves, it is obvious that we only have one curve element. So that is why I have to insert this square bracket and index number 0. So after curves join curves and curve, it should have one curve. So I take simply the index number 0's curve. And then finally, there is a loft command or loft method in Brep class 2. And by using this, loft itself was introduced by Machine and Svere from the first day, if I remember correctly. So the loft is taking a series of polylines and connect this smoothly. So breps.create from loft and polylines, this collection of the lines of the edge curve on the different level, and we have other input parameter which is necessary to generate this loft. I think it's better if I go to Rhino command. Create from loft. So the command I'm using is this command or this method, and it requires 5 variables. You cannot omit any of them, so we have to input anyway. And this second and third parameters are optional. So if you wanna have better control on your resulting loft, you should make use of these point 3D types. But for the moment, I don't need it. So there is instruction: use point 3D dot unset parameters of point 3D class if you do not want to include these points. So I took this option. And loft type is corresponding to what Martin explained on the first day. So it corresponds to the various loft type. Either it is normal, it is straight, or it is developable. And this functionality we have to define here. And finally, this closed input list to choose if you want to have a closed type of Brep where the first element of the polyline and the last element of polyline is connecting smoothly. And in our case, it is false. And then, so this is the simple explanation of the task 7. As I mentioned, I will create one video doing step-by-step procedure. I think hopefully today and at least within this workshop period. And the resulting surface is looking like this. So if I bake this, if you have learned the bake part of the bake feature, so it will transfer the data to Rhino geometry from Grasshopper. So you can find this by either right-clicking or center-clicking the mouse and select this bake button, and you see this shape in Rhino too. It is now overlapping with Grasshopper elements, so it doesn't look very good, but you can switch off Grasshopper preview here on your top right corner, this icon here. So this is my resulting facade element, and when you want to go back, please press this red icon instead. Okay, so so now I'm running behind 3 minutes, but please I appreciate if you have additional 1 or 2 minutes. So I have already prepared additional contents called Help Movie series. For this, you can have access from Mural board. Here we have I have 1, 2, 3, 4, and additionally here 5, 6 movies corresponding to the GH5 or GH C# component from left to right. So the content is written here, so please feel free to watch this. And also, I really wanted to explain about this functionality of importing C#, CSV, comma-separated value files, and make use of it within Grasshopper. And probably the nice thing to have is the exporting feature outside of Grasshopper into another CSV file. So this I would also like to introduce you. So I make 2 videos, right? One is to present CSV to make them accessible within Grasshopper, both read and write. And the other is the step-by-step instruction of the task 7 component. Yeah, this is all from me. And thank you for joining in this morning session. I'm a bit running late, but I hope you or we have learned something out of it. Yes, thank you very much. And this is the last. Also the last session of me, so please feel free to contact me personally by using emails or Teams or some other channels. Yeah, thank you very much.
Okay, we are back. So this time we will go into the Visual Studio and train some basic C# creation, and we will try to create our first plugin in Visual Studio. So raise your hand if you see my screen. You should see Rhino 6. Okay, perfect. Then I hope all of you installed Visual Studio. So I have at least Visual Studio 2019. All of you should open it. And now maybe you here don't see this one because those are the recent projects which I have been doing, but all of you should see the on the right side those buttons here. I will create a new project. And I will just use random C# or let's see what we have, some maybe desktop. Um, the most basic ones will be it can be this, an empty project for creating a local application, empty project.NET framework. So we'll go for this one. So we'll call it first app. Here is the place when you want to create your code. So where you want the whole project will be saved. Solution name, let it be first up, and then let's go for create. So this is how Visual Studio is looking. And now some of you, what I will order all of you to do is to go to extension and manage extension. And those of you who didn't install, I want them to install a Grasshopper template. So I am typing Grasshopper here. And I have a Grasshopper template for V6. I already have installed it, but all of you should have it. I have a green arrow here. If you install it, then remember to do this. If you will install it, probably, but right now, let's just stick to the first app. I will go for the, okay, explanation. File, new, save, those things are in any kind of the software, so it's kind of the easy one. The most relevant for us will be this build solution, and rebuild, clean, and things here. Also the project, first up properties. It's also something which we'll be using. So I will add in the project, I will add a class. And remember, everything what you are doing, you in the C#, it's mostly creating a class. So I will click add class, and here I can add class 1, and I'm choosing this one, class C#, not empty rhinoceros or grasshopper. Right now we want to just create an empty class. I will click add. And we have class 1. Now what I will do, I will add to this project another thing, which will be add component. And I will go for the component class. I will add it. Let it be. I will come back to the class 1. So here you see that everything, every time you are adding something new, you have a new window here. Right now, maybe we'll be just working in one, but if you right click here, you will have something like close all tabs, close all but this. So here you can, because later you will see that you will have plenty of them. So remember, right clicking on one of them will give you some options to either close, either delete one of them or several. So I will delete this component 1CS, but it didn't disappear. Here in the data tree structure on the right side, we have a solution explorer, and we have all of those still open. So although I close the window, it doesn't mean that I delete the file. The file is still here, and also it is in the folder which was used to store the whole project. So if I again double left click on this component one, I still can retrieve this component or a class, depending on what I want to do. So I will delete it and stay back with the class one. And class one, let's try to build this solution. I will build this solution. So here at the bottom, we have an error list, which is saying the class with C# is not available. Then probably, are you sure that during, okay, I will go back to, let me see one thing. Here is the instruction which I was, it's here from the beginning. When you are installing, here you should have this net desktop development marked in. If you didn't mark it here, then maybe you should modify this and or restart your installation. But anyway, we will be working in the Grasshopper soon. So this is just for explanation how how you can operate in the Visual Studio. So I will make a break in a couple of minutes and come back to you if you still have this issue, or I can help you individually. Okay, Visual Studio. And we have a class. I hope at least some of you have this class. Or can you raise your hand if you have this class C#? Okay. So unfortunately, you are some of the people have it. So you have to wait till the pause, and I will individually help you. So if you have a class, in general, you can in this class make operations like double d1 equal to 0, double d2 equal to 0, and you can make also double which will be result and d1 plus d2. So you see that generally most of the things yeah, one thing, the Visual Studio will help you during creating a code. So when you have, you are creating a double, it's quite visible that I can zoom into this. And generally the objects are turning into or the name of the classes are turning into the green. The data types are turning into blue. The variables are white, and the values are like also white, or maybe I'm not sure. But if anything is wrong, like here, then you will have this red wave under your variable. So in here, we will have the information that we cannot use non-static field method or property class one d1. It's because we should create what should be done in any kind of the C# class. We should have at least one main function, main class in any code. But this is not so important, because here I want to just explain you a little bit how the Visual Studio is looking. So you can make as many classes, of course, as you want, but to be able to work in as a one, it has to be in the one common namespace. So this namespace first up, it's very important, because if I will create the second class, let's call it class 2. And again, I will use double d2, or again d1 0, double d2 equal to 0, and double result d1 plus d2. Then it will turn in the I add the word public, because now this information d1 will be able to be read by the class 1 in the whole namespace. The thing public, it's corresponding to what, in which dev in programming you have the access to which variables. And also it's the same for the classes. So if I will make a public class, it means that I will be able to use it in even if I will create I will go for the project, add a new class, a C# class. Then since I'm in the same namespace, I will be able to use a variable d1 or d2. So, okay, but this is just, we will go directly to the creating a Grasshopper project. So what I will do now, I will just close it. So if you have any errors, it will be in the bottom. If you have a data tree, like the information about how the code is created, it will be on the right side. Here you will have all your classes, and generally each time you will be opening something, it will be here in the top and ribbon. So I will just delete almost everything here, and I will go for the new. Yeah, those one of you who install the Grasshopper plugin, they have to restart the Visual Studio. I will do it like you. So those of you who use the the Grasshopper template for the C#. And now when you click create a new project, you should have, when you are typing Grasshopper, you should have an add-on for V6 C#. Raise your hand if you have it, so I will be sure that, okay. So those of you who doesn't have it, because everything now will be working on this. So if we will make 5 minutes of break, so we are back on let's say 12:50. And those of you who doesn't have it, just let me know, write me privately on the chat or something, and I will talk with you how to solve this. Okay, I hope there was no private messages, so I hope all of you have this Grasshopper thing here. So let's start. So I am typing Grasshopper add-on for V6. Double left click. My project will be first plugin. This is just a name, so whatever you will call it, it's up to you. And let's create it. And here is a little bit of writing. I will just make a print screen because later if you so the first plugin, let it called first plugin component class, let it be first plugin component, the name first plugin, nickname, let's make it first. Category. What is category? Category is when you are opening Grasshopper. Category, it's generally the name of the ribbon. I will call it maybe parametric workshop. Sorry, here. So I will call it PC 2021. Subcategory simple. Description. Let it be first component ever. And I will provide a sample code. Sorry, no, I will not provide because it will change my description. I will leave it like it is. So I will just type first code ever. I hope all of you have it here gray, but if you have it red, this means that you need to find some of the files. For me, at least, you see the shortcuts here. So in program files, you can find the Rhino 6 plugins Grasshopper and then find DLL file. So click here and find this file. If for the Rhino common to the same, so Rhino 6 system Rhino common DLL and Rhino exe Rhino 6 system Rhino exe. So I will click finish. It's creating a project. I have to say that in the Rhino 6, it's very easy to create your first plugin. Let's go it. So let's go for it. So we have a first plugin info CS. This one we have the name of it. We can always change it, but we'll go directly for the first plugin component. Here you see the first plugin component name. I will zoom in. So first of all, here you know it a little bit from the Rhino and Grasshopper. Here are the libraries, so you can type using and some kind of the name of the library. Commonly, they are DLL files. And you can add new ones, so or make a shortcut for the existing one. So later we have a namespace. Like I was saying, it's very important to be in the same namespace in every class which we will be doing to be able to talk those classes with each other. So right now I put a small minus here. So in the namespace, I have just one public class, which is called first plugin component. I will open this one, and here I see have a little bit more of classes or methods. So public class first plugin component is inheriting something from GH component. Those two dots are saying that we are creating an object which will be inheriting of properties from the class which was made previously. But this one we will never change, so it will stay here forever. If you will change it, then you have an issue. You will have to remember how to do it. So maybe even restart the project. But this is, remember, just text. Later we go into public first plugin component. This is the name of our plugin. It's generally the same as here is the name. we have, and this is the same. It's inheriting some properties, and here we have first plugin, which is a name, ASP. So you remember I sent you the picture of when we were creating first time the component. We have a popping out window in which we could specify those names. Right now they are here, and we can change it whenever we want. So if we want to move it to the different category in the Grasshopper, for example, I would like to put it into the Caramba 3D, then I just have to write here Caramba 3D. It's a little bit not so trivial what is what, but if you go over the base, you will have some small introduction or a tip, and you will see that the first string which you are putting here is a name, the second a nickname, the third is description, the fourth is the category, and the fifth is subcategory. So it's really easy to write a code in the Visual Studio and much faster, because the debugger, the Visual Studio, is helping you and advising what can be added and what cannot. Later we have another class which is protected override void, which means that it will not return anything. Protected, it means that you cannot correspond to this in different classes. And here you have input, and these inputs we can declare like this. Yeah, one thing. Here you have a name of the variable, and we will use it to declare our inputs. So I am typing pmanager and then add, and let's take text parameter. I am opening the method. So this is a method, and the Visual Studio is helping us. So he wants to have a name, nickname, and description. So I will just put apostrophes here and call it first input. Then I will create a shortcut, FE, and the description. This is first input. It is a text. And lastly, the most important thing, that we have to declare what kind of the input it is. He is helping us, so he per default is choosing GH param access. Then we have to put a dot, and then we are specifying if it's an item, list, or tree. I will go for the item right now, and after this whole formula, I am putting semicolon. So this is the code which I just created. I will just put it into the into the chat box. So if you want, you can copy it from the chat. Yeah, the same thing we would like to have as an output. So registered output params, and we are opening this class and start to write pmanager, add text parameter, and to not make it maybe too long in names, I will just create first output, FO, description, output, and again GH param access I will set to be an item. So this is the second line of the code, which I will paste in the chat box if you want to copy. And the main thing, like the main code which will be running, is this solve instance. So we will be solving our issues and our components, problems, everything just right here. So again, I will type variables. I like to make comments like this, and also outputs. And in between these brackets, we will create our main code, and we will be creating this main code during last days of our workshop. So first of all, we have to somehow take our input. So I will type DA, which is the EH data access DA variable, and I will get data. So I will put a dot and then start to write get, and the get data should be there. You see already that alternatively we have get data list or tree. So this should light up the bulb in your head that if you will be using here not an item but the list, here you will have to use not get data but get data list. Okay, let's make this get data. I will open the brackets, and of course he is helping us. So first of all, index 0 and the reference to the object which we want to assign to. So I will make here a text and put here the word reference. It means that we will reference to some of the variable, but we don't have this variable yet. We have to declare it first. So I have to make a string, which will be called text, and it should help us. Yeah. I have to declare at least to be an empty. So I put a equal sign and empty apostrophes. You can type here default text. Okay, so we have our variable. Then the algorithm will check if there is an input connected to our component, and if it will be, he will assign this text to this string variable. Easy, easy. So then the only thing what I would like to do is to assign this text again to the output. So I will go for the DA, and I will this time set the